So we have to find limits, these limits, and we have to find x plus y intercepts. So the limit as x approaches negative infinity from x e to 3x. This is not a friendly situation per se for negative infinity. So this piece goes to negative infinity, but this piece, when x approaches negative infinity, this one goes to 0. How come? It's e to negative infinity. 3 times negative infinity is negative infinity. E to negative infinity is 1 over e to infinity. And we know that this is extremely small. Now, in these situations, we use something, a transformation, which we haven't discussed in this class. So in order to find this limit, some of you, I'm impressed, some of you used this in the previous test, which is called the L'Hopital's rule. We used to talk about this rule in this class, but for some reason not anymore. I teach this rule in Math 191, but not in your class. But I saw many of you, several of you, 2 or 3 of you, used it on the previous test. I accept it. It was not discussed in class, but it's a legitimate method. So this basically will be changed into, it's a long story about L'Hopital's rule. L'Hopital's rule can only be applied in 2 situations, only in these 2 indeterminate cases, not in 0 times infinity. We haven't even talked about 0 times infinity. I think that this problem should not really be in this book, but we picked the problem, so we have to finish it now. So 0 times infinity is another indeterminate case. You can say, but that's not possible. 0 times 5 is 0. How come that 0 times infinity is an indeterminate case? Yes, it is an indeterminate case. This does not equal 0. It may, but it's an indeterminate case like these 2. In other words, no clue. Anything can happen. So 0 times infinity cannot be considered 0. It may turn out to be 0, but it cannot be considered 0, like 0 times 5 or 0 times 1 or 0 times anything else but infinity. So this limit, in order to be able to use L'Hopital's rule, which uses derivatives, I have to change this function like this. Now the numerator goes to 0 and the denominator goes to 0. By using a simple manipulation, I brought it back to L'Hopital's rule. So 0 times infinity can be very easily changed into 0 over 0 or infinity over infinity. And we have to continue from there. I'm not going to discuss all this because, as I said, it's not part of this class. I'm going to leave it alone, and we're going to find the limit here in a different way. Not going through all these steps. I don't want to confuse anyone. Okay? So this will be determined. To be determined. Not with L'Hopital's rule. The other one is very easy, because infinity times infinity is very clear. There is no problem here. But at negative infinity, I have to show you more steps, and it involves L'Hopital's rule. We're going to figure it out without L'Hopital's rule in a minute. Okay, now I need to find the x and y intercepts. So 0. When x is 0, 0 times 1, because e to 0 is 1, 0 times 1 is 0. And there are no other x-intercepts because x times e to 3x to be 0. X can be 0, but e to 3x can never be 0. How come? It's this graph. e to 3x is this graph. It never touches the x-axis. E to 3x can never be 0 or negative. So this is the only option. So after all this analysis, we can say we're done with the function. Yes, we will figure out this in a moment. So now we move on to the first derivative and then to the second derivative. It's a long story because this is not very easy. It's a product. This will be even slightly more difficult because it's a product. Two products, actually, after we differentiate the first time. Okay, so let's continue. Can anyone help with the derivative of this function? X times e to the 3x. X times e to 3x. How do I differentiate this? First function prime. First function prime is how much? Yes, so it's 1, so e to 3x. Very good. X times. Can anyone differentiate the second one for us? How do we differentiate e to 3x?
Would it be x times 3?
You mean e to 3x? E to a function prime is e to the function times the inner function prime, which is?
The x.
The inner function prime.
Oh, straight.
Very good. So now we factor e to 3x, and we have 1 plus 3x. 1 plus 3x. Yes, I have to set it equal to 0, or set it equal to undefined. Not possible. This is always defined, and this is a linear function. Not possible. When I set it equal to 0, this could never be 0, but this can. So we get x equals negative 1/3. This is the only critical number. This is always positive. Don't bother with it. But this can be positive or negative. To the left of negative 1/3, negative 1/3 is negative. To the right is positive. Now, I have to find this number, this value, the value of the function at negative 1/3, because I have to find this y value. So, not a friendly function, as I said from the very beginning. Where is my calculator? I put the function in, and I have x times e to 3x. Okay, and then when I plug in negative 1/3, I get something impossible to graph, but that's what it is. Negative 0.1. Okay, so I put it in the table as negative 0.1. How am I going to plot negative 1/3 comma negative 0.1? We'll see. Okay, so the function is decreasing till this number, and then increasing, and then continues to increase. Positive, positive, from negative 0.1 to 0, increasing, from 0 to infinity, increasing, and here it's decreasing. So we're going to figure that out in a minute again. Good, we're moving on to the second derivative, which is even more difficult to work with. So I differentiate this, which is 3e to 3x plus, this is a product. It's 3x e to 3x. So the first function prime is 3 plus 3x times e to 3x prime. which is e to 3x times the inner function prime. So this is 6 now. And this is plus 9x e to 3x. Yes, I have to factor out e to 3x. 6 plus 9x. I should have even factored out 3. 3e to 3x and 2 plus 3x equals 0. Impossible. So when I set this equal to 0, I get x equals negative 3/2. No, negative 2/3. So where do I put this in? I have to redo my table because there is very little room. So I'm going to put here negative 2/3. I have 0 here, but very difficult to read because I need more room in the table. So I have to copy the table in a minute. So I also have to find this value here. How am I going to plot negative 1/3, negative 0.1 is one thing. How do I plot negative 2.2 divided by 3, which is negative 0.6, and comma something? So we'll see what that something is. So with this exercise, I'm showing that it's not very easy. Some functions are not very friendly. So negative 2 divided by 3. So it's how am I going to plot negative 0.09? Nobody knows. I don't know. We're going to make it happen, but it's not going to be easy. Okay, so again, the same thing. These are all positive. So to the left is negative. To the right is positive. So this opens downward and this opens upward. This is a relative min. This is an inflection point. And I'm going to copy my table because no one can read it. I can, but no one understands what I'm doing here because it's too crowded. It's clear, but it's too crowded. So I have to copy the table so you understand what this is all about. Okay, so f prime of x, f of x. And no, you don't have to ask. I'm not going to ask something like this. I'm not trying to torture you. I'm trying to teach you. Okay, so this is a 0 here, a negative and positive. And this is negative 2/3, so there's 0, 0 here. This is negative 0.1, and this is 0 here, and this is negative 0.09. So I'm gonna plot the difference between negative 0.1 and negative 0.09. Very difficult. And positive. And this is relative min, and this is the IP, and this is infinity. Okay, so let's give it a shot. I don't even know what unit to take, right? What unit? And how do I show the difference between those two? We're going to make it happen. Okay. So here it is. So at negative, so I'm going to say negative 1/3, negative 2/3. I have to redo my table. No one said anything. I'm trying to finish this weird problem. And I have to come back to this. Did anyone notice what I did?
Did you put negative 2/3 and 40?
Right, exactly. I want to finish it. Exactly. Exactly, that's exactly what I did. That's exactly what I did. Unacceptable. when I realized immediately that it doesn't make any sense. So negative 2/3. Thank you for noticing, yes. Because it didn't make any sense. When I put it here, I said, no, that's correct, but this is not correct. Good. Okay. So we'll plot the points first. Anyway, so I'm going to plot something. So this is here, and this is a little bit higher, and yes. Anyway, I'm trying to finish this, and it's not working for me. Okay. So negative 0.9. So it comes down to negative 0.9. So from somewhere, we'll identify in a minute. I am tempted to say that this is 0. We'll see in a moment. So from 0, decreasing and opening down to the point of inflection. Why I say it's 0? Because there is no x-intercept here. So we cannot cross the y-axis, the x-axis. Not possible. So that's why I'm saying 0. Opening down to the point of inflection. It changes concavity. It comes down to a relative minimum. Changes concavity, comes down to a relative minimum. It crosses at 0, 0, continuing to infinity. The graph is not difficult. It turned out to be quite simple. But getting these numbers and identifying the inflection point and the relative minimum was a little bit cumbersome because of the function, because of all this work that needed to be done. So that is the graph. Now, we should also check. You should always check with the graphing calculator just to make sure, but be very careful how you enter the function. Now I know exactly where the action is, and it's very tiny, around between -2 and 1. So I know exactly where to graph the function. -2 and 1, maybe 2 at the most, with a scale of 1 is okay. Y minimum, very tiny, right? So -1 at the most. And the positive part, I don't know, maybe 2, with a scale of 0.5 or 0.25. So it should come from 0 down to -0.09, continue down to -0.1. Who can see the difference? And then crossing at the origin and going to infinity. Now we're graphing. That's it. So it's coming from 0. Why I knew that it cannot cross the x-axis? Because there is no x-intercept on that side. It cannot cross. It cannot come from anywhere else but from 0. Now the inflection point is somewhere at, I have no idea. I can't tell you where -2/3 is, but I'm assuming somewhere here. Maybe about here. And then it turns, opening up, crosses at the origin, and going to infinity. No, you're not going to have to deal with something like this on a test. As I said, I'm not testing endurance.